Good morning. It is pre-coffee and I'm going to do a video on transformers. By the way, I've been told that when I show these videos in class that I tend to go too fast, and I'm sorry about that. You guys can watch these again later if you need to, but I do need to um, go fast enough that people who have trouble paying attention, the pieces of the story come together pretty quickly. This allows us to exchange voltage for current. All right, we're going to have something that changes voltage but also changes current. We can step up and step down the voltage. Here's how you build a transformer. And I'm a little worried about this black pen. It's got the big paintbrush hand, so let's go with a smaller one. You need a iron structure, and I'm drawing it as kind of a big rectangular structure with a hole in the middle. And this is called the iron core. This is designed to channel the magnetic field from one place to another. It's a fact of nature that magnetic fields love to be inside of magnetic materials like iron. They rather go through iron than to go through the air or the vacuum. So if you give them some iron to go through, you can channel them and make them go there, and you can also make sure that none of them miss their intended target. Now, on one side of this iron core, we are going to wrap some wire. I'm showing two wraps of wire here, and we're going to connect this up to a source of AC voltage. To be specific, we're going to go ahead and make this 120 volts AC. It has to be AC. You'll see why in a little bit. On the other side, we're going to wrap more wraps of wire. I'm going to try to draw three. Yeah, let's do three wraps of wire on this side, and this will be hooked up to some sort of resistor. And that resistor is going to have a specific value. Let's make it 10 ohms just for fun. And what's going to happen here is that the primary side of the transformer is going to make some magnetic field, which is going to travel around and go through the secondary side of the transformer and be picked up. This is the primary side, and this is the secondary side. Primary where we're making the field, secondary where we're picking it up. Primary where we're providing the voltage, secondary where we're going to measure the voltage. And at each of these places, Faraday's law is in effect. Now, I've substituted V for the epsilon that is usually used in Faraday's law because we know that the EMF is really just a voltage. And I've also neglected the minus sign. It's not important here. V2 equals N2 and the rate of change of the flux. And what's interesting is because of the iron core, all of the flux and all of the rate of change of flux on the primary side shows up on the secondary side. So these two things right here, these are the same. So if we do a little algebra, we can show that V1 over N1 is equal to the rate of change of the flux. And that's also equal to V2 over N2, leading us to the big equation of the day, the transformer equation, V1 over N1 equals V2 over N2. This is the transformer equation. So, story so far, we are creating magnetic field, magnetic flux, channeling it over and picking it up. We have a different number of windings that are creating it than picking it up, and so there will be this relationship in effect. And the upshot of that is that, let me rewrite this, V2 equals V1 times, now we're going to have N2 over N1. This ratio, N2 over N1, is called the turns ratio. And that determines how this thing behaves. In our example here, V2 equals 120, the voltage that we put on there, and then we have 3 over 2. So 120 divided by 2 is 60. 60 times 3 is 180. So we had 120 volts on our primary side, and we're going to show 180 volts on our secondary side. This is a step up transformer. It increases the voltage. On the other hand, in a hypothetical situation where their turns ratio was less than 1, like let's just say that we had 120 and we had a turns ratio of 1 turn on the secondary side for every 2 turns on the primary side, then we would have a 60 volt thing showing up on the secondary side, and this would be a step down transformer. You can step them up and you can step them down. It doesn't matter. But whatever the turns ratio is, secondary to primary, pickup to delivery, that tells you what the transformer is going to do to the voltage. Now, I think we all understand that voltage and current are in some sense opposites to each other. Let me see if I can do this here.